This yellow also 5 millimeters, and this is 60 millimeters LED. DC voltage, and then to power up a small DC motor. Let's try this one. Okay. Great. Hello Hacktubers, and welcome back to my channel. Today is Sunday, 16 October 2022, and of course I have a new video for you. Okay, here I have a pack of a bunch of LEDs. Some are 3 millimeters and some of them are 5 millimeters. For example, this red LED is 5 millimeters. And now, imagine that 12 times bigger. Okay, in next minute or so, you're gonna watch how I made a homemade DIY epoxy resin LED diode that will actually work, and it's around 60 millimeters, the case that I'm using for the epoxy resin. Take a look. Take a look. This is 5 millimeters LED, and it's tiny. This is okay. Let's measure. 62. It's working. But I don't know, can you see it? There is a crack, a big crack. Here it is. You can see it. I don't know why. So I decided this surface to be clear and turn out cool. And this top side I sanded very smooth. It's not perfect, but it's okay. 60 millimeters, and it's heavy. And just to mention, before testing this, in next videos I will use my homemade big NA555 timer chip. This will be good. Okay, power supply for this. Okay, here it is my digital power supply. I'm gonna set on 3.2 volts, and here we're gonna watch how many amperes or milliamperes is pulling my LED before I tell you which diode I place inside the epoxy resin. Okay, this is positive, this is negative, and here it is, the crack. 87 milliamperes just to kill the lights. Five millimeters, 60 millimeters. Big difference. Okay. Hello Hacktubers, and welcome back to my channel, and I have a new video for you. And today's video is all about this guy. What is this thing? It's a 3D printed sand crawler from Star Wars, and I printed in mini form, and it's a mini toy that looks very cool. The filament is brown, and these wires are for what? Okay, to explain. Beside the 3D printed toy, I have added wire LEDs. Those are very small LEDs on wire, and I glue the wire with 2-component glue. And by the way, this is wireless or battery-less gadget or toy. It's a sand crawler from Star Wars, and here is the magic. Why this toy is batteryless? Because I'm using a copper coil. Here it is, between these two parts that needed to be 3D printed, and that coil, copper coil, is receiving the power energy and then transfer to the LEDs, and then this 3D printed toy will light up. Okay, I have made a couple of wireless gadgets or toys. Here I have a flying DeLorean with wireless energy on the LEDs, epoxy Lego with LEDs, and here it is, the latest sand crawler. Look at that, the LED is working. The front white, from side green, and back pink, just to kill the lights. Now it's much better. This is the smaller one. It's a 8mm red LED, and on that LED I made a copper coil. Here it is, the latest, looking nice. How I made it, you're gonna find out in next minute. In link below this video I'll put the links from Thingiverse. You can download the thing and 3D print it yourself in any size you wanted. I want small stuff. This is a miniature sand crawler, and I have added LEDs, and in next seconds you're gonna watch how I made it. Besides that you need to 3D print it, the two parts, you need a LED wire with those tiny LEDs, and luckily I have in random colors, so I use that LED wire and glue on the 3D printed part, like so. I have a couple of videos that you can check in links below how to make the receiver coil, but in this case for this toy I made it a small receiver coil out of 30 loops of copper coil, solid copper wire, and that coil is fixed on the bottom part of the toy, and directly on ends of the wires just solder the LEDs, and that's it. Okay, that was all for today. Short video about making mini 3D printed figure with adding some wireless LEDs and making that toy to be batteryless, working on wireless energy, and turned out pretty cool. And this is new toy for my wireless stairs. Alright. Hello Hacktubers, and welcome back to my channel Hacktuber. Let's start the video with this AC motor, which is a fan from a heater, and I power up just letting you know that it's working motor that will be converted into a transformer. By removing all mechanic parts from the motor, example removing the rotor, with this step we make a space for winding my solid copper wire. I'm using around 10 meters of 1.3 mm copper wire diameter wire, and this takes me around 2 hours to wind all the wire. It's hard, but not impossible. Next step is making a isolation out of thin cardboard using 2-component glue to make solid base for the wire coil and making secondary coil output power. I am done with the second coil. This is the primary coil for input of AC 220 volts, and that is the original coil from the motor. And this is the secondary coil, and this coil will give output AC voltage. Now I'm gonna test it. Okay, here I have my digital multimeter just to measure the voltage of input and output. plug it in. On these alligator clips we have a 220 volts AC, 234. Okay, let's check the secondary coil, how much volts it's giving, AC volts, 3.3 volts. Okay, that is enough for the experiment, but this thing is giving AC voltage. What does it mean? It means that we need to convert it into DC voltage, direct current or alternate current, and this is 50 amp bridge rectifier. I will use this in my next project. You have a small bridge rectifier up to 1.5 amps, but I'm using in this experiment this bridge rectifier. Okay, I have already soldered a electrolytic capacitor of 1000 microfarads, 16 volts. Right now I'm gonna solder the bridge rectifier to the output wires from the transformer. Okay. I'm done, and now I have a positive and negative pole, because this bridge rectifier converts the voltage from AC to DC. And let's check it, does it work? Power on the transformer. Let's see it this way. Okay, positive to positive, negative to negative. Oh, the wire is desoldered. Working. Okay. So from simple AC motor I made a transformer from 220 volts down to 3 volts AC. Then through this bridge rectifier I convert AC to DC voltage, and that is given by this power supply. And how much? 8.5 volts, but it's not stabilized. Let's power on these Piranha LEDs. This goes here. No. Alright. Come on, man. Yep, it's working. While the LEDs are turned on, I'm gonna measure the voltage of today's power supply, and it says 2.9 volts DC. Okay, now I'm gonna try it. These 60 plus LEDs all connected together. Nope, this is the negative, this is the positive, and working. Okay. Now let's measure the voltage. .6 volts. Okay. From AC motor transformed or converted into a transformer that give AC voltage through the bridge rectifier, I transform that AC to DC voltage, and then to power up a small DC motor. In this video I only wanted to show that you can make a transformer out of AC motor, and it's working great. Okay, here it is, the first plan that I write on the paper. Here it is, the 3-volt coin battery. Here will be 5x5 LEDs, 3 millimeters, 25 LEDs, also 25 micro switches for controlling the LEDs, plus one switch for the main power. Here I made a small circuit diagram for how to connect all the LEDs and switches. Also I'm using 5 rows, and for each row I add 100 ohms of resistor. And I'm not using a resistor for each LED, but I'm using a resistor for each row, each grounded row. So we have 25 LEDs that are controlled by 25 switches. Alright. And I forgot to tell you that for making this gadget you will need for around 190 plus soldering points. 190 soldering points to make this gadget. Whoa. I start the project with placing all 25 red LEDs 3mm, placing on the universal breadboard, also placing 25 mini micro switches, 3-pin switches, and also placing 6 resistors with 100 ohms, and we need to solder 190 soldering points. And below the board with solid copper wire I made all the connections between switches and the LEDs. 25 LEDs, 25 wires going from the LEDs to the switches. Totally 190 plus soldering points. As I said, with those 25 micro switches you can draw letters or numbers, or you can even play a game. What do you think? What game you can play? Comment below this video in the comments below. It's like a badge, but without using a microchip to control the LEDs. It's a hand-controlled LED matrix, and you can draw a letter or sign and wear it on your jacket like a badge, and program it without programming, with controlling the switches. I like it. This is the circuit diagram, and just to set. Okay, I have all the parts that I use in the project. You need 25 LEDs 3mm, 26 switches, 1 coin battery, 1 battery holder, 6 resistors, and PCB board. All total 1.99 cents or $2. For making this gadget you need $2 for parts. And this was designed by me. Great stuff. It turned out a pretty portable LED gadget. And this is good. Let's try this one. Okay.